Hey guys, how goes? Martin here. Welcome to my channel and to this particular engine lid project, which was about 5 years in the design and making. We are going to get right to it, what is involved in order to do this, what parts are currently available, and to perhaps inspire you with some ideas if you are doing something similar. You can also follow me on Instagram, where I post day-to-day progress and reels, discuss options, parts updates, and sales, etc. as they become available. First of all, what was the point of this project? The answer is threefold. Aesthetics. It would be great to have a view into the engine bay while keeping some basic, unwanted things out. Honor the OEM lines and design something that's exotic yet still Toyota Lexus. You know, look fast standing still. Simple, right? Secondly, we want to have increased airflow up and out of that engine bay to get rid of heat. And finally, if we can decrease the total detachment of airflow after the roofline with perhaps smaller vortices and less wake for overall aerodynamic improvement, it would be another win for our boxy yet apparently timeless platform. I mean, this is the X-Wing fighter equivalent in the Star Wars universe. I began with the engine lid. This is the later fiberglass version with the raised vent sections. It was then filled with low expansion foam for some increased rigidity, but in this state it still remains fairly floppy. The raised inner edges were left to help with keeping water out. I don't drive the car in winter or on rainy days, but it does happen. Haven't given thought yet to car washing, but done okay with a cut open lid for a few years, so pretty confident I'll figure it out. When I get the car repainted in the future, I'll finish this lid properly. Back around 2017, 2018, I made some really rough sketches just to see if my interest was piqued. I don't offhand recall if I stuck to those measurements. The OEM trim was kept and repurposed as much as possible. The top clear OEM deflector was part of the design. That brings me to the next big decision that had to be made: how to make the louvers themselves. Ideally, making them the same way as the OEM deflector is absolutely the best for rigidity, but this requires pressure forming, the use of top and bottom or inner and outer molds, along with heat and pressure. Both sides need to be perfect. Pressure forming is extremely expensive. I got quotes for tens of thousands of dollars per mold. The facilities that can do this are limited. It's often reserved for mass production of thousands of units. The ones we would need are over 4 feet in length, and we need 7 of them, distinct in shape and size. So this is what brought us to 1/8 inch Lexan sheet and a rear bend in each piece for simple rigidity and water retention. There is still a lot of flex, especially the rearmost edge, and some gravity droop, although minimal. These are going to shimmer with engine and road vibration. Personally, I don't mind one bit, but it is something to be aware of. I considered designing them slightly longer towards the back so as to also bend the rearmost edge down, but I figured to try them this way first. Another bend would also change the look, and I've learned from this project especially to never assume what something will look like. To mount these and provide the structural rigidity for the whole lid, the concept was borrowed from the contracting realm in the form of staircase stringers for a floating staircase. But they had to look fast standing still, be light, strong, and have attitude. I opted to have them essentially disappear due to the dark powder coat color, but they have much more presence if they were to be a light color. And so the Stinger stringers were born. Their spiny appearance are reminiscent of a stingray, or several stacked, and so, hence the name Manta-back. The math required for the CAD file design for both the louvers and the Stinger stringers was well over 100 pages long. To mount the stringers on the lid, I ordered some readily available mounting brackets for generic spoiler kits. They came with these feet that I just had to widen the gap a bit with a grinder. You might notice that with the raised edge design of this fiberglass lid, I had to angle the outside 2 stringers ever so slightly inwards, as in toe in if we were to apply wheel alignment terms, and the rear feet sit slightly wider. This has no negative practical or aesthetic repercussions. What was a challenge was the fact that our engine lids are not flat, with a slight convex design, but the stringer levels and the louvers do have to be absolutely flat. So the center stringer has slightly shorter legs to compensate, and all stringers sit perfectly 90 degrees to the louvers. To protect the fiberglass structural integrity, the lid underside surfaces were built up with 1/8 inch aluminum pieces to give good flat surfaces for the bolts. Now, the top mounting bar needed to be constructed to lock everything in place and provide the mounting points for the roof hinges. I elected to keep the bar completely out of rear window view, and so mimicked the outside shape of the rear glass exactly. But if some people didn't care about that, it would simplify things a fair bit with a straight bar across that needed no bending. Bending aluminum isn't actually that hard if it's done gradually, equally, and kept straight in the other planes. This is 1-inch square tubing, about 1/8 of an inch thick wall. Bolt some 2-inch or 3-inch, 1/4-inch thick steel square tubing to a shed or garage wall and run the aluminum through it and bend at measured lengths. Next, I constructed the curved ends of the bar. I didn't know how long they needed to be, so I made them a bit longer just in case. Some TIG welding, shaping, and clean up with a flap disc grinder, and then try it on the stringers to cut it to the correct size. Some 3/8 inch or 1/2 inch pieces of aluminum plate on either end make for a flat solid surface to bolt the stringers to. The center stringer is sandwiched between two 1/8 inch legs, and then all vice gripped together for now. You may have noticed the center stringer is nearly the perfect height, whereas the two side stringers are longer than they need to be, and we can cut them down as required. Next, the rearmost foot of the center stringer needed some attention. It's only a 1/4 inch thick in order to sit flat on the raised section above the latch. And so a flat spearhead stinger was designed to interlock with it and would give it added strength as well as a finishing aesthetic punctuation. The spearhead is welded to the center stringer. There is a 1/8 inch spacer of either PVC or ABS underneath the spearhead to align it with the two side stringers. The spearhead was drilled and tapped, and the two bolts from below were cut so as to not protrude up into the first louver. Now the lid is ready for a test fit. Make sure that the lid sits exactly flush with the surface of the trunk lid and adjacent valence pieces all by itself, supported on rubber stoppers, etc., because this is the position we need to fix it in. It needs to be able to return to this same fitment each time we put it in place. I even wedged the gaps between the lids so as to keep everything straight and aligned. It was good to go. The 3 top bar attachment points were drilled and bolted to the stringers with 2 bolts each. Time to tackle the hinges. The bar was drilled and tapped to bolt up 1/2 of the stainless hinges using a steel rod to ensure alignment with each other. Then the hinges were cut into by about halfway through to make it easier to create the correct angle to bend them at, so that they would pivot exactly where we need them to sit flush on the edge of the roof and still be aligned with each other along the pivot axis. Not gonna lie, I wasted about 6 hinges getting this right. This method allows for some tweaking. Just avoid going back and forth because it creates deeper stress fractures that can snap. I'll show you in just a second why we are doing this. Okay, see what I mean? Making some sense? Once the angle is perfect, they can be welded in 3 small spots on both sides, alternating them as you weld them to keep them balanced and honest. It's all we need. Welding the whole length can torque and change the angle as it cools. New holes are drilled and the excess we don't need is cut off. In case you're wondering what these bushings are at either end, they are custom tailored to each hinge by the manufacturer to ensure a tight fit. I considered many different fastener types for the hinges where they attach to the roof. It was by far the simplest to blind rivet them, and it worked perfectly. Yes, I am riveting on an unwelded hinge here. I needed to test to see if this blind rivet idea was going to work. What a satisfying sound. It only took a minute to drill the rivets out and weld this up after. Use stainless rivets, or rust, corrosion, and discoloration will haunt you down the line. Next, I have to tackle the latch. It has to be moved forward into the engine bay because the direction of travel from the lid is coming from the back more and moving towards the front. So my latch has been a Tercel latch for quite some time, ever since my MK 1.5 swap. As with everything in this engine bay, it is a tight fit. It's already low profile and sits right back against the firewall. I'm going to move it as far forward as possible with some spacers and some new mounts, but I'm limited because of this large plenum that's in my way. So I'm going to have to modify my trunk lid just a little bit to allow the travel of the latch as the lid comes down to pass through just the top edge of the lid. The catch loop on the underside of the lid also had to be cut and the angle changed and re-welded. Others might have success with the original OEM latch and may not have to modify that trunk lid at all. Right, welded up, riveted up, can you believe it? It's hinged at the roof. We are going to spend more time demonstrating exactly where these hinges are located in a few minutes, and it's best to demonstrate this in relation to the OEM trim. For now, let's look at the modified trim. The roof trim piece needs to be cut out to straddle the hinges and shaved a bit underneath too. The OEM clear deflector needs to be trimmed all around so that it will fit with the uppermost louver and accommodate the hinges. The metal channel with its attachment clips needs to be gently and persistently worked after the cuts are made, and it will come off. Then the pieces can be bent and repurposed, flipped around, and then glued back onto the modified deflector with E6000 glue, giving it new attachment points on the top bar. Now, finally, I was able to place the louvers in position for the first time. I left the protective plastic in place. Doing this did confirm for me that their shape was good, and the horizontal line aesthetic effect was successful. This was the point at which the whole project was either deemed aesthetically viable or whether it should be scrapped and never spoken of again. I went to sleep that night feeling encouraged. It meant that tomorrow was powder coat day. I'm not going to spend too much time on the powder coating part of this project. I went with Misty Midnight so that the Stinger stringers would basically become part of the cabin of the car. But the powder coating was very challenging because there are so many areas of these stringers that are known as Faraday cage areas. It's time to drill and tap all those Stinger stringers and assemble the louvers. Just a heads up, big drum fill coming. Told you it was a big fill. The clear deflector can now be installed for the last time. True to MK 1.5 spirit, the screws are a pain in the ass to reach. Definitely stuff some towels down there underneath to catch the screws because you will inevitably drop some of them in doing this and they'll go down into the engine bay and probably be heard forever and seen never. The clear deflector has 4 attachment points to the bar, but it still requires at least 2 more to keep the trailing edge of it locked down. See those 2 powder-coated bolts in the center of the frame? I bolted a wedge-shaped chunk of aluminum to the outside of the stringer that goes right into the corner of the clear deflector. There are arguably many ways to do this, including using a clear glue, but I'm going to attempt to drill and tap right into that corner. This allows me to disassemble at any point. I'm using the towels stuffed underneath there again to keep the shavings from going into the engine bay, and then a microfiber cloth picks up the shavings really well. Just never use it again for anything near clear plastic after that because it pretty much becomes an oxy scrub pad. For these hard to reach tapping spots, I always use a drill on a slow setting. This is actually the cleaning pass I can afford to one hand the drill and phone in the other. I'm proceeding gingerly because if you listen carefully, you can actually hear the tap bottom out in the dead end hole. Here, I'll give you guys a top-down view of this wedge-shaped piece of aluminum that I added to the outside of the stringer. With the other stainless hardware going on, you don't even notice this screw. See? Are you still looking for it? Okay, I promised you guys we would look at the hinge locations now that everything is bolted up. You can see that the hinge sits fully behind the roof trim piece and fully inside the clear deflector. It is also protruding about halfway up and out of the clear deflector. I think the goal is to have a 90-degree pivoting range for this lid so that it can be pretty much straight up in the air. Set up in this way, I'm actually getting about 140 degrees of engine lid range. The last thing we want is to rub or crush or crack that clear deflector in the center. I still need to solve what type of support strut setup will help this lid open. Stay tuned for that on Instagram. And this is the moment that I actually stood back for the first time and looked at the result. I was tripping over my tools and my welder. It's actually an irreconcilable conundrum, a result that exceeds the sum of its irreconcilable parts. I'll explain what I mean. You knew I would. From the side profile, we have a concave shape. The louvers purposely get longer and flare at the bottom, while the shape of the louvers are angular and pronounced. From all rear perspectives, we have a convex shape. The angles disappear and we have a rounded appearance. And from a level perspective, everything appears flat. A quick word about overall weight. I'm a stickler for adding weight, and I've done everything possible to make this strong and light and rigid. And this is a compromise of all those priorities along with aesthetics. This project will add some weight over the OEM lids. I believe the OEM ones weigh around 12 pounds. But for those already running things like engine lid fans and stainless shrouds, it could be a direct trade-off. The only way to get lighter is to redesign thinner pressure-formed pieces thinner than the OEM deflector. So, what is currently available for parts to make this happen? The stringers that fit the fiberglass AW11 lid with the raised vents and the louvers with the front edge already bent up are available to order immediately. They are not drilled or tapped, and you would be responsible for the rest of the project. This is the least expensive way to get started. I'll be gauging interest on Instagram to accommodate as many different needs as possible, such as modifying the design of the center stringer to mount on the early model AW11 flat metal engine lid. I'm currently looking to have the mounting feet locally made, but the generic spoiler mounting kits they came with are available from random sellers right now. I'll post those details up on Instagram as well. I have to recheck price quotes on everything because it has all fluctuated so much this past year or two, so stay tuned. I am also open to partnering with other vendors who are interested. Okay, I'm going to offer a critique of my lid cutout shape that you guys might want to consider. This corner right here is just underneath the edge of the bottom louver. I think perhaps a shape like this will work there. Heads up, I'm going to hit you with the drum fill again.